Welcome, everyone. Thank you for coming. My name is Jimmy Bogard, and today I will be sharing some of my experiences of introducing OpenTelemetry into existing systems that either had some kind of observability stuff going on, or maybe none at all, but definitely nothing in terms of anything OpenTelemetry. So we'll be covering a few things. First is just an overview of what observability is, what OpenTelemetry is, and finally we'll look at why you should care about OpenTelemetry if you have existing systems that are today not doing anything OpenTelemetry related. Now, OpenTelemetry is a standardization effort, and with any kind of standardization effort, you get like the classic XKCD situation, where you have n competing standards, and so someone says, right, we need to standardize the standards, and so now you have n+1 competing standards. When I first got started with OpenTelemetry back in 2019, 2020, it was definitely in this sort of arena where we didn't know if OpenTelemetry was going to, quote, like win out against other competing standards. But 5 or 6 or so years later, it's become evident that OpenTelemetry has basically won, and it's safe enough for us to use, definitely for new systems. But today's talk, I want to focus mainly on existing systems that don't have any of this stuff in place. So how did I first get introduced into OpenTelemetry? OpenTelemetry started out in 2019 or so, and this is also the same time frame that I was dealing with a client in which we were building out, you guessed it, microservices, and we were needing to have some kind of visibility into what was going on into the system. This system, as it existed back then, was microservices, and every single service had its own individual MongoDB database that it was storing all of its information into. So of course we started out simple. There was just like 1 or 2 services, but eventually grew to like, I don't know, I think at the end they had like 16 or so different microservices. Probably could have just gotten away with like 3, but you know, microservices, more is better, allegedly. So here we were. On top of all of these services, we had an Angular front end. So the Angular front end would call into APIs that the different services would expose. And for most things, this was good enough for the different screens to be able to get the information and perform actions on each of these services. But there were also occasions which services needed to coordinate with each other. And so for that, we used RabbitMQ to facilitate messaging and async communication between each of these different services. This is all hosted on a cloud platform, which I'd never heard of, and I hope I never see ever again, called Pivotal Cloud Foundry. Does anyone here how to deal with this thing? Oh, a few unlucky people out here. So yeah, I'd never seen this before, but it is supposed to be a cloud agnostic cloud, which is just like another cloud that you're coupled to, and this is where all of our services were then deployed to. Finally, of course, we had the end user that was using some browser, and that browser was really kind of coordinating all the operations between each of these different services. So they'd kind of start in the first step of the process, they click some buttons, and that would kind of shuttle them to the next service and the next step of the process, and on and on and on. Now, when I came on, we were building these services out, and I just sort of relied on this cloud provider thingy, Cloud Foundry, to give us the observability to be able to peer into what was going behind these services. But it turns out that really didn't have much to speak of in terms of observability at the time. So really what was happening was everything was then actually being funneled out to Splunk. And that was the only observability tool that this team had at the time. So for a lot of things, like in a single monolithic application, this is probably good enough. You just like output logs to Splunk and sort of call it a day. But when we started to get to more complex distributed systems where we're using both synchronous API communication and these asynchronous messages, this becomes a huge challenge for us to figure out what the heck is going inside of this. So when we deploy the system out into any environment, we no longer had any visibility into the individual services. We basically just had like the browser talks to like the stuff, and then the only thing we could really see out the other side was the stuff being pumped out via the logs into Splunk. So at that point in time, the team's like, okay, everything works great locally. It always does with microservices. But when we push it out into a deployed environment, we can't tell when something goes wrong. We don't know what went wrong, where, what service it was, or the specific sequence of operations that led to some sort of specific failure. And so the issue we had was, in this system, there was a lack of observability. So observability is simply the ability to observe a system from the outside without knowing about the inside. So you don't have access to all the little things going on underneath the covers. You can only observe the system from the sort of outside interactions or signals that exist in that system as it is today. Now, in order for us to be able to get information from the inside and be able to see it in the outside, then the inside needs to emit information about what's going on. And this information is also known as telemetry. Telemetry will tell you, okay, this thing happened at this point in time, or it took this amount of time. This is the thing that called me. This is the thing that I called to other people. It gives us all that level of detail, but it needs to be able to be emitted from inside that system, inside that application, via instrumentation. This Cloud Foundry thing had something known as auto instrumentation, which I wouldn't wish upon my worst enemies, because it works great for the very simplest of scenarios. But anytime you try to get more information past what is just automatically stock out of that system, you're left wanting more. It's just not going to give you that extra information. So we realized that what we were given today was just sort of pure logs being pushed out to Splunk. And if the only thing you have is log information pushed out to Splunk, then you're actually spending most of your time spelunking, which I guess is why they call it Splunk. You're spending most of your time just trying to dig through logs, trying to figure out, okay, what actually went wrong here? And we'll do things like, okay, what specific time of day did you click that button, right? And so then you go to the logs and try to constrain yourself to a minute of time. Hopefully that minute of time, the time zones match up and the clocks match up to give you that set of information. But if your system is under any sort of regular use or heavy use, then even that little sort of time frame window is nowhere near enough. So we realized that we were missing a lot of information here, and we needed to have our system emit more information, more telemetry than it was doing today to something. Maybe that's Splunk, maybe it's something else. So these telemetry signals, these are the sources of instrumentation data that we want to turn on in our system, or if they don't exist, then start to add them and include them. The telemetry signals, these are known as signals now. They used to be called the pillars of OpenTelemetry or pillars of observability, but that metaphor doesn't mean the same thing to everyone. So they're really just signals. They're data signals spitting out telemetry data to be listened to by some kind of UI or some system that can gather that data and then present it to you in a nice user interface. The first one typically we see in systems for telemetry signals is logs. Now logs is what most people have today, right? Most users today, most systems today have logs as a source of telemetry data. And this gives you some information, it gives you when this thing happened, when this specific telemetry log event happened. It gives you some data, some message about what the thing that happened, and maybe there's some metadata associated with that log entry, but usually not, right? Usually it's just timestamp, message, and that's kind of all you get there. When we're looking at distributed systems, though, a straight log message is not enough to understand if I have some kind of causal relationship between different systems, that this system calls this system calls this system. I would love to be able to connect those different pieces together and see that these different kind of actions are all related to each other. Now, logs can kind of do that in some specific cases, but really what you would rather have is a telemetry signal that is more specific to that kind of use case, and this is known as a trace. Traces are differed in logs, and that traces also contain an identity, that you know that this specific distributed trace of all these different connected actions that have happened is different than some other thing that has happened, not by something like a timestamp, because those things could have happened at exactly the same time, but also there's some identity associated with this specific connected set of operations versus some other connected set of operations. Something that's also different in traces, which are a connected set of spans, they're known as. Spans also include a duration with a start and end date. So I know when the thing started and also know how long this specific operation took to perform whatever this thing is. there's a lot more that can happen inside of these spans, which I won't cover in detail, but this is now a thing that people are starting to attach more and more data to because it is this nice like identifiable thing with an ID. They can say, hey, this other thing is related to this thing with this specific ID. We also have metrics. Metrics, you can again kind of put together metrics based on the other two pieces of telemetry information. And some people try to do this, but honestly, it's a lot easier if you emit these metric signals as their own individual measurements, rather than trying to piece like the Humpty Dumpty picture together based on like, oh, I saw this log entry and this log entry, and I saw those this many times. So that means I had this many open connections to the database. It's a little bit easier just to capture that sort of signal like as a top level concern. But there are also other signals. There's one called baggage, which I won't cover today, but it is a thing that exists. And I guess like vibes could be another signal, like how many vibes do your application give off? I don't know. But the three main ones, though, are logs, traces, and metrics, and those are the big ones that I see on a kind of a project-by-project basis. Those are the ones that I use all the time. All right, so we're back over here, where I realized that just the logs being pumped out to Splunk were not enough. I couldn't piece together the history of this thing calling this thing calling this thing. And so what I like to do is have my Brownfield legacy, or really just existing system, emit signals to the various different kinds of telemetry, I guess, consumers and visualizers. So of course for logs, we had Splunk, but we also introduced a couple new ones. One was traces to Zipkin at the time. There's a few others out there, like Jaeger's another popular open source one. Another one, like I've used App Insights or Azure Monitor, or what is that what it's called today? I don't know if like the AI folks have decided to name it something else at Microsoft. But those also have built-in capabilities for viewing distributed traces. And for metrics, this client was also using an APM tool, which, again, I feel like I've gotten in the wrong space because those tools are so insanely expensive. Like I really should have gotten to that sort of thing. But they were already using Datadog for their application performance monitoring. And so we said, hey, this thing can also do any other metrics we pump at it. So let's then use Datadog to do this. So this was, again, like 2019. I said, okay, we know we got a deficiency in the tooling, so let's add these other two tools. But the problem I quickly ran into is that for all the different kinds of sources of telemetry signals, they didn't have necessarily all the support for these third-party tools. So what I was looking for was like, okay, I have this sort of signal. What telemetry tool is that sort of signal source supported on? So something like HTTP client, right? Every time I call out to a third-party API or another API internally, I would want to make sure that it supported each of these different tools. But that also got multiplied by all the different potential sources of telemetry data. Like whenever I talk to a database, I want to get telemetry data out of that. If I just have logs randomly in my application, then I want to make sure that those make it out to these different sources as well. So what I quickly saw is that this is going to turn into this terrible matrix madness, where for each different kind of thing I was looking at measuring, each component of observability, I had to go then check to see, is this supported in my telemetry tool of choice? And what was inevitable was like some of them supported all of them. Actually, none of them supported all the signals. They would have like different varying levels of support overlapping in some specific areas, but usually what I saw was that there was going to be some pretty big lift on my part to try to fill in the gaps of the different sources of telemetry data, and then plug it into the different telemetry UIs and providers here. Now, this is something that back in those days was such a huge pain, because we would also see like SDKs of these different telemetry providers. They would like have a new version of something, and that would break all the existing stuff that we had going on because they changed something with the API. So it was kind of a constant churn we would see when we were having to support all these different things. And I also saw that if I moved on to the next project that has some other telemetry provider, like this one used Zipkin, the next used Azure Monitor, I couldn't use any of the previous extension code. It had to be all thrown away and started from scratch of like, well, what is Azure Monitor's way of doing logs, traces, and metrics? And then we build a whole bunch of other custom plugins for those specific things. So the goal of OpenTelemetry is to try to standardize all of those sort of things. Now, this is ambitious. And so what we'll talk about in this talk as well is what are the different kind of, what are the things we can adopt from OpenTelemetry where we don't have to necessarily do like this entire matrix of everything OpenTelemetry, but still provide a win for our clients, our customer, your employer, whatever. So OpenTelemetry is an observability framework designed to facilitate the generation, exporting, and collection of telemetry data. It's open source, it's vendor and tool agnostic, and it's not meant to be a replacement for the backend itself. So it is not a collector of all the telemetry data and giving you a nice user interface. That will still be your Zipkin, your Jaeger, your Azure monitors of the world. What it's intending to do is to let you stop like directly targeting those SDKs of those specifically telemetry tools, and instead use a more standards-based approach. So this is 2019, and this has only happened like 2 or 3 times in my career where I'm presented with a very complex problem that could have a very challenging implementation, only to do a Google search, because thankfully ChatGPT was not there to lie to me about what actually existed. And I saw this blog post from Microsoft that said, hey, we're going to improve troubleshooting and monitoring distributed apps by embracing OpenTelemetry. I thought, oh, thank God, because I did not want to have to develop all these sort of custom plugins myself that are going to be thrown away and have to maintain over the years, that instead Microsoft is committing to this. So when I talk about a brownfield war, this is really what I'm talking about, is a system that does not have any kind, it may have have some level of existing observability, almost certainly is not directly using OpenTelemetry, and probably has all sorts of customizations and stuff going on behind the scenes. What you also typically find is that there's usually a very low cardinality of telemetry. If I'm looking at just the Splunk example, usually what it is you have a timestamp, and hopefully you can kind of like get that timestamp window small enough to like catch your log entry between all the others. So it's very difficult to find your information amongst all the other set of data that's going on there. It's usually only logging, right? You've only got logs being pumped out somewhere, and then that's maybe Splunk is like, yeah, we can do traces too, but it's a lie. They're trying to like infer the tracing information from logs, and that's just a really difficult thing to do. The actual log output itself can often be in a hard to reach place. Is anyone here still like logging to files on a bespoke server somewhere that you have to log into the server to see those files? There's some like very hesitant hands, like, oh, I don't want to raise my hand. But I'd say that's definitely still the case as well. It's like you have to remote desktop SSH into the production server to go view the log files over there, because there's so much difficulty in changing that to anything else. But what is most often the case is there's tons of vendor-specific extensions that either you or someone else has developed and pushed out on a package somewhere that was updated maybe last like 3 years ago and does not support the current SDK. And you're probably often seeing a lot of like custom user abstractions over those telemetry APIs, right? Because you don't want to couple yourself directly to Splunk. So instead, you're going to have an abstraction over the logging to Splunk, and then you're actually using that abstraction instead. Or you don't want to couple yourself directly to Azure Monitor, or whatever it might is. You don't want to have that vendor-specific code littered throughout your application code. You have your own special individual abstraction over that telemetry data. But really what you're getting to is you're trying to, when something goes wrong, you're trying to find a needle in a stack of needles, and you're only going to get it hurt, right? You're going to put your finger in there and get poked 10 times. That's the wrong one, and you have to dig through it again. Now, we could continue down this path of, okay, I'm going to go Zipkin. I got to adopt its model, its SDK, and just extend that instead. But there are some specific reasons why I think you should be picking OpenTelemetry for Brownfield. Obviously, the big one's like get off that old vendor jank into the new OTel, making that bank sort of thing. But a big one I saw was that everyone's doing it. What I mean by everyone is the tool vendors, the people, the Splunks of the world, the Zipkins of the world, the Azure monitors of the world, they are adopting OpenTelemetry. And a big reason why is because it's actually cheaper for them to do so, because they only have to implement an extension once, as opposed to, okay, this this random client has its own specific abstraction of telemetry data. So I needed to write a plugin for their telemetry generation SDK for my collection SDK, and these vendors have to maintain this matrix. It's much easier for vendors to maintain just a single collector for OpenTelemetry versus, or exporter for OpenTelemetry versus having to support everyone's kind of custom sort of thing behind the scenes. And it's not just Microsoft either. A lot of the standards we're looking at and OpenTelemetry itself, if you look at who the sort of backers of those are, it's all the big backers. It's the Googles of the world, it's the Microsofts of the world, of course, it's the Amazons of the world. They're all buying into this model. In 2019, 2020, back then, it was a risky bet. But at this point in time, the Microsoft, like all the SDKs that you're using today, almost certainly are directly targeting the OpenSDK APIs. But it can be a challenging decision if I have an existing system that has a bunch of customizations for a specific vendor tool. And I have to ask myself, I've got 8 extensions to this this vendor tool. What's wrong with just adding one more extension to that vendor tool? Because I've already invested in those previous extensions I made. So I kind of look at this as a trade-off of I can just sort of continue to extend the vendor-specific SDKs and APIs, but at some point you're maintaining all this infrastructure code that someone has already solved for you in this other target of OpenTelemetry. And so you have to make the decision of, can I throw away all this code that I don't really want to maintain to begin with and adopt this? So it's a decision of either like sort of extending what you've already been doing or investing in the future that could potentially open up a lot more possibilities. But it also could be that we just don't have a choice for adopting OpenTelemetry, that we have a specific hole in that matrix, and what fits that hole is the existing OpenTelemetry extensions for that specific vendor. And so it's much easier for us to adopt that versus looking inside of what that code is doing and realizing, oh my gosh, I don't want to have to maintain this 2,000 or 3,000 lines of code that is so specific to this vendor. I don't want to have to maintain that. So it could be just an easy choice to say, let's just use what's already there. The final big one, though, I found is by embracing this OpenTelemetry standard, there's a lot more extensions to that standard than what almost certainly exists to the vendor-specific APIs that you would be having to use today. So what this would do is enable more choices for options and architectures of our observability solution that we would not even consider if we're still just doing more one-off extensions to the vendor's APIs. So what might this look like in terms of an existing solution with no integration with OpenTelemetry and to incrementally migrate that over to an OpenTelemetry full stack solution? So I break it down first between your application code that is generating the telemetry signals and exporting them with the observability server, the vendors that you're depending on. Because there are basically two things that I can control. I can control my application code and the dependencies that I'm dealing with. And then I also have then all the observability server APIs and UIs. And apologies that the O11Y is a numeronym for observability. It was the only way I could fit observability in that space there, but I freaking hate numeronyms. They're like the inside joke of a group of friends that no one understands. Like, Ollie? Who's Ollie? No, it's observability. So looking at these different, this client and server, we have the things that are application controls versus the things that are at the server side. On our application side, we have two components. We have generation of telemetry data. This generation of telemetry data could be in infrastructure code that you don't even see, like deep inside of ASP.NET Core, deep inside of ASP.NET Classic as well, deep inside of Entity Framework. Inside of these SDKs, the telemetry data is actually being generated. You just may not know that it exists. So that is still part of our user application code, though. You also have code that you write. You have your logging statements that you're writing out and your actions that you're performing. You may have custom traces, but that's much less frequent. Usually, what you have is custom log messages that you're spitting out. So we have our logs that are being generated by application code. These are being exported inside of our application to something. And that something is then some kind of plugin to the logging framework and to then the third-party telemetry server here. So if you're using like Log4net, Serolog, Nlog, whatever, then there's probably some plugin to that logging provider, to the telemetry provider, hopefully. Same thing with traces, right? We have our generation of our tracing data, the exporting of the tracing data out to some kind of third-party server, which exposes an API to collect, store, and then visualize that information, and of course, metrics as well. So in order to migrate my application code, the things on the left, over to OpenTelemetry, I need to understand, well, what am I migrating to? Now, this part is the one part that is pretty specific to Microsoft and .NET, because every single kind of language platform, Java, Node, Ruby, Python, whatever, they had an existing starting point of where they were with observability in that platform's framework. Some platforms didn't ever have any sort of standard of any of these telemetry signals. So in .NET, for example, what was the standard logger before ASP.NET Core came around? There wasn't one, right? Every system you built, you had to decide what is going to be my logging provider of choice. Is it going to be Nlog or Serolog, hopefully Serolog, or like if it's a really old janky application, Log4net, right? So there was no standard of the logging provider. So .NET's a little unique in that some of the pieces were already existing inside the framework that did some of these kinds of signals, but some were not. So I break it down in terms of looking at what is the right tool of choice to pick from here, based on first the different OpenTelemetry components at the top. And then on the left side, we have the different telemetry signals. The components being generation of telemetry signals, exporting to some other provider, and then finally collecting and visualizing over there on the right. And the signals then being logs, traces, and metrics. Now, OpenTelemetry does define a standard SDK API surface area that says if you want to be like OpenTelemetry targeting the OpenTelemetry standard for generation of this, here's the defined standard. And here's the methods, here's what the parameters should be, all that sort of stuff. So at Microsoft, though, this was ASP.NET Core 3.0. They had already introduced a standard logger, which is Microsoft Extensions Logging. This is the standard logger that you probably use today in your newer applications to generate logs. You say, I'm going to depend on an iLogger of T, and then I will log different levels, and that gets spit out through there. So what Microsoft has done is shape that API to help to better match the SDK standard of OpenTelemetry. It does not match exactly, but that's okay because, again, Microsoft said, rather than us throwing out our whole SDK and just straight up adopting OpenTelemetry, which then all this user application code would have to be rewritten to this new standard, instead we'll just kind of massage this library to be moving towards that standards approach. On the export side, this is when there's not really a standard here. There's just like extensions to say, I want to export this signal to this other thing. And so for logging, there's usually some NuGet package, right? We're like, I want to export my logs to this thing. And there's almost certainly some NuGet package that says, I know how to export the standard iLogger of T thing. These are known as what, logging providers? Yes. They know how to export those logs to something. By default, of course, you get like what, console? Console, yes, is like the one that kind of comes out of the box. But if you're going to export to something else, then you can find that package that will do that exporting for you. Tracing is a little bit different because the tracing API in .NET predates .NET Core altogether. So the tracing API was put in place to help show traces in Azure App Insights, which again predates .NET Core. So instead of having, again, a completely new SDK, what they said is, right, what we'll do is we'll again massage our existing API, which is in this package, the system.diagnostics.diagnostic source, and says instead of having to rewrite all this infrastructure code, instead we'll just move this API towards the OpenTelemetry standard. But one of the downsides is like none of the names match of this API. So you just kind of have to translate in your head. When they say span in .NET, it's called an activity. But it's the same concept, same idea. And basically from 3.0 on out, they were heavily focusing on targeting the API surface area, but without like renaming stuff, because that'd be such a pain. On the exporting side, this is where you see a shift, where the OpenTelemetry folks have a contrib repo that has now the exporting of this standard tracing data to then third-party telemetry servers. So you'll have some kind of exporter extension that knows how to translate from activities in .NET to whatever thing we have on the other side. So for whatever thing you have to go for, like if you want to go to Zipkin, there's an OpenTelemetry.exporters.zipkin package to export these traces to Zipkin. But it's still like, that's one like kind of a minor annoyance here that, okay, well, I do have one vendor specific library, but it's not in your application code. You're not writing custom Zipkin span logic in your application code. It's all standard diagnostic source activities. Instead, there's something then takes those activities and pushes them out as whatever Zipkin needs on the other side. Now, metrics is one that actually does sort of directly target the OpenTelemetry standard because it did not exist when OpenTelemetry was first formed in 2019. So this package, the system diagnostics.metrics, already right, better name. System diagnostics.diagnostic source. I don't know what that means, but it's not a very user-friendly name. Metrics, though, was designed from the ground up to match the OpenTelemetry standard. And it just so happens that Microsoft folks are on the standards team, so if they don't like what they're seeing, they can tweak the standard, I guess. Similarly, though, to export that out, we have OpenTelemetry.exporter.something. You find what you want to export to, and that's what you're going to export. Finally, on the collection side, this one's a little bit different because the collectors are the APIs those telemetry servers expose to receive telemetry data. And so this is one that I find is like a little bit less of a win or value added to an OpenTelemetry solution, but there is a standard for the wire protocol of telemetry signals, and it's known as the OpenTelemetry Protocol, or OTLP. I will show an example of this, OTLP, but again, to me, that's a little bit less valuable than the code that I'm actually dealing with on a daily basis, which is more the things on the left here. Now, one of the other really great things about this is these libraries support, especially the generation libraries, support every supported version of .NET Framework and every currently supported version of .NET Core, whatever they're calling it, like .NET 6, .NET 7, .NET 8, 9. It supports every currently supported version except for the really, really old one, .NET 3.5. It's still supported for like, I don't know, another 3 or 4 years or something. But I don't know, if you're still in a .NET 3.5 application, you probably have other problems you're dealing with than just like observability. So this migration process in practice really would start at the biggest wins, which for me are typically the signals at the top. Like once I get logs now going from like some custom API to something else, now I can do a lot more interesting things with that. So it basically starts out with migrating the generation logic over to OpenTelemetry, and then migrating the exporting logic over to OpenTelemetry, and then doing the same with traces, migrating the generation logic, which is probably a lot less in your application, and then migrating the tracing exporting, and then finally the metrics as well. So I kind of see this as a sort of a progression where I started with sort of the easy wins with logs and start moving up to the less frequent but still valuable telemetry data here. So let's break this down then to each telemetry signal, and then I'll show an example of what it actually looks like to migrate old jank to the new bank based on these different signals. So first is logging. Now logging you probably have in your application today. Otherwise, I don't know why you'd be here if you have zero telemetry data, but maybe that's the case. It's doubtful that you have no telemetry data whatsoever. You probably have some kind of logging going on there. But almost certainly you're using some sort of third-party library to do so, and a log4net, an nlog, a serial log, some third-party library. You may have a custom abstraction. Who is using one of these third-party tools and has a custom abstraction on top of it? Your own internal logger class thingy that you're using to, just in case we ever change our logger, we have this custom abstraction. Maybe you're using Microsoft extensions logging, but I tend to find that that's not the case for existing legacy systems. It's usually there's some third-party library and some bespoke custom abstraction. The exporting, it's usually an extension to that third-party library and is going to be some sort of custom abstraction because it's so specific to the logging generation library and logging the target you're trying to push the logs to. That is that kind of intersection of the matrix that says, do I have Splunk exporting for Log4net? Hopefully. If I don't, then I have to build that myself. On the collection side, I do see this occasionally in some places through things like log aggregators. So that's, what is it called? Cloud Foundry tool has a log aggregator. Your system actually can't export logs itself. You're supposed to spit everything out to console out, and then they take your console out, pump it through a log aggregator out, and then to something else. So you may have something there, but usually it's not. You're not going through a separate aggregator in the middle. Usually you're exporting directly from your client application straight out to the logging sink, whatever that is. All right, let's look at an example here. And I wanted to show a .NET 4.8 example, so I have to go to my Windows VM running on a Mac ARM laptop. So everybody cross your fingers. We'll see how this works. Okay, so yes, this is a .NET 4.7.2, sure, why not? Console application, which just does something very stupid, right? It creates a service object, tells that service object to do awesome things, which is just to say everything is awesome. That's all it's doing here. And so when I go ahead and run this, it is spitting out log messages, but how is it doing that? Let's go take a peek at this logger class, and we can see that it is using Log4net. Yes. So in this application in which we're using Log4net, it is doing our class is doing generation, but we're pushing out to this custom abstraction, this logger abstraction class. So we have our own methods of like log.info, and all that does is just call log.info. Like, wow, such value here that all we do is just call log.info. And so yeah, it just turning around and calling out into Log4net. Log4net, I had to Google this and find like a 10-year-old Stack Overflow post about how to actually initialize Log4net because I totally forgot how to do this. So it's doing XML configuration that has appenders, and so, oh, there's our console appender that is then how it spits onto the screen. So Log4net has its own set of abstractions to do so. Okay, now to get this over onto Microsoft extensions logging, one thing I have to be careful of is I don't want to replace everything all at once. So I could look at this and say, okay, well, let's just delete Log4net altogether. But this config file is probably where a lot of your intelligence is like the configuration of your logging, third-party logging provider. So whether you're using Log4net, nlog, or serial log, whatever, you probably have a lot of setup code in here about exactly what the format needs to be. And I don't necessarily want to throw all of that away just to get over to OpenTelemetry for generating log messages. So what I do is I search, is there a shim for this logging provider to Microsoft Extensions Logging? And it turns out that there is. There's a shim called, where are you? Microsoft.extensions.logging.log4net. ASP.NET Core, even though there's no dependency on ASP.NET Core. I don't know why the name of ASP.NET Core is out there at all, but it is a shim between Log4net and Microsoft Extensions Logging in the generation of log messages. So what that means is that I can still use Log4net for the exporting of my log messages out to whatever, but now I can start to migrate my internal application to using the traditional or the Microsoft Extensions Logging SDK instead. All right, so I'm not going to remember how to do this. I'm just going to uncomment code and explain it as we go. So first step is initializing this, this shim between the Microsoft Extensions Logging Framework and Log4Net. So that happens here. I create this logger factory. This is Microsoft Extensions Logging definition of loggers. And then I had the shim here that says add log4net, and I pass it the name of the config file, which is what you see over here as well. And then finally, I can then, from there, create an ilogger of t. So that's what I'm doing here, is creating an ilogger of logger, yo dog, where I've got a logger here. And now instead of using log4net's generation of log messages, instead what I'll use is this ilogger of t. So right here. Now, what is really helpful here is that if you're depending on other components that are also using Microsoft Extensions Logging, now those logs will be showing up into this common exporting logic of log4net. So you got now that one pinch point that either it can come from log4net or it can come from Microsoft Extensions Logging, the generation of those log messages. But now, I mean, the name's a little different because I give it logger.logger, but whatever. The same log message can be now either generated from this log4net logging generation, or it could be pumped out via the ilogger of t. Both of these work from here on out. Now from here, what I'd probably do is then move towards getting rid of log4net altogether, like migrating to loggerfactory.add. Oh, I don't have, add console logging, add Splunk logging. I'm more likely to find the exporter there than I am for log4net. Okay, so logging, we can incrementally migrate over from the whatever custom stuff you have going on, even looking at, if you're still using this static API, I can first migrate over to using Microsoft Extensions Logging, and then over time, remove the usage of that custom wrapper class altogether to directly use ilogger of t, because then everything's set up there ready to go. Tracing's a different story though. You probably don't have any code in your system, in your user code, that is generating custom traces. It's almost certainly happening though underneath the covers in your infrastructure code. So ASP.NET, back to like ASP.NET 3.5, I think, like 15 years ago, has tracing generation inside of it. You just may not have known because it is only ever lighting up if you deploy to Azure and enabled App Insights. Then there's some like line of code somewhere deep inside ASP.NET that's like, if I see this environment variable called App Insights connection string, then I will then export the telemetry automatically to Azure App Insights. So that's all there, just kind of waiting for us to tap into it. So our current state is a little bit different here, that there's probably no user code. Maybe there are some custom extensions that you've written on top of App Insights or whatever tracing provider you're using. Almost certainly the dependencies that you're using have tracing inside of it, targeting the diagnostic source API, the activity API. But it might be using some alternate custom standard for propagating the distributed tracing information. Because I'm now in distributed land with traces, service A calls service B calls service C, I need to connect those dots together, put Humpty Dumpty back together again. And so there will be some kind of extra metadata information I need to take advantage of to connect these different actions and operations separated both in distance and time. On the exporting and the collecting side, these are going to be extensions specific to your dependency server. So there's somewhere that's like, here's my app insights SDK.initialize. Here's my telemetry GUID or whatever they have today. So it's something in there that says, here's how to export out to those third parties. Now on the distributed tracing side, what I was mentioning around the alternate custom standards is really around the tracing headers we're using to connect these different systems together. One common one out there is known as B3 propagation. This came from Zipkin. So Zipkin, when I have some server calling another server, as part of that call, it will append additional headers in the HTTP calls so that the receiver of that receives the incoming headers, and when it pumps out telemetry data, it says, hey, I am now process 2, and I'm related to process ID 1. So I have this sort of linked list or directed acyclical graph of these different services using these headers to have IDs to be able to have pointers basically to point to all these different operations that are happening. Well, that's just one standard, okay? As part of this effort for OpenTelemetry, the team at Microsoft and others said, okay, we need a standard that's yet another standard to standardize the header information to connect these distributed traces together. And this is actually now W3C accepted, final, good to go status, known as the trace context standard. I didn't put the full trace context header because it's like really long and would just like stretch across the screen. But it's now the accepted W3C standard to be able to connect these different things together. But that's not certainly the only one. Anytime I have systems calling other systems or systems initiating something in different systems, there's probably a need for observability, and someone's come up with their own sort of header standard as part of this. In an example, I will show you a different standard for messaging that's out there as well. All right, so let's look at an example for tracing. I'm going to switch off of .NET 4.7.1, and now I'm going to be looking at, this is now a .NET new applications, .NET, thank you, got it, on it. There we go. So this is a more complex example of a complex distributed system where I have an initial API application that then leverages messaging via RabbitMQ to initiate other actions and operations. And those other actions and operations are also doing other stuff like calling MongoDB or calling SQL, calling something. So right now, the other thing this application is using is Aspire. Now, the reason I chose Aspire is because Aspire is an exemplar of an OpenTelemetry collector. This is, Aspire has API endpoints that know how to speak the OpenTelemetry protocol to be able to collect, organize, and visualize logs, traces, and metrics in one like the best observability UI you'll probably ever see. But don't put it into production, please. It's not production ready. Okay, so let's run this and see what we see. Okay, so here's our application. It's just an API with two stupid API endpoints, say something and say something else. But what these do is these kick off messaging interactions behind the scenes. But right now, if I run this, this is my Aspire dashboard that shows all the different services and resources for this application. So I have RabbitMQ. Let me bump up the fonts. There you go. And full screen, why not? So I've got RabbitMQ here. I've got MongoDB. I've got Jaeger that does distributed tracing. I've got Zipkin that does distributed tracing, because why not? And then I've got my actual applications here at the bottom, the child web and worker. But if I go look at logs and traces, oh, there is something there. Forgot to turn that one off. And metrics, there's really nothing going on here. So right now I don't have, like, it's not, there's user code that is generating telemetry data, but it's not hooked up to any kind of exporter or collector here. So let's do that. So one of the first things I will mention here is that Aspire is not just for, like, what is their tagline? Like, build cloud-ready applications, blah, 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 blah. It's also really good at, if you have distributed systems, to be able to orchestrate them together and provide a really awesome local development experience here. One of the things that Aspire provides is this service defaults. And service defaults are out of the box, like, provide like sort of resiliency and observability defaults that you want to put into every application. but you don't have to even use Aspire to do that. I have a blank solution here. If I just say right-click, add new project, and I say I want to add an Aspire service defaults package or project, this also gives me a great understanding of like, what is the right way to register OpenTelemetry in my application? So very often I'll just like download the newest template of this thing, create a service default, and just look at the code and be like, what's the right way to do this right now? And this tells me how to do so, because inside of here, it's got extensions that are like services.add service defaults. It's got, oh, configure OpenTelemetry. How do I do that? Oh, you got to do this thing for logging. You got to do this thing for metrics. Oh, look, there's instrumentation for specific metrics. And then finally, there's tracing that has, okay, I've got the source and whatever. And then finally, you have exporters down here. They've got an OTLP exporter, which is what the Aspire dashboard speaks. It's an OTLP collector, the standard API format, which also means you can use the Aspire dashboard for anything that generates. They can export OTLP format. So if you have a Node app, they can export OTLP. You can use Aspire dashboard for that as well. Okay, or I can have other ones, like here's Azure Monitor for exporting out to Azure Monitor. This line of code here is probably the most expensive line of code you'll see in this demo, because now I have to turn on Azure Monitor. Okay. Okay, so first thing I'm going to do is in my service defaults, I'm going to uncomment some things to start to light things up. And child worker, yeah, whatever. Okay, service defaults over here. So we saw that there was something in here to add logging. So I'm going to do that first here. Add logging. Yep. So let's just turn this on and see what happens. I'm going to run this again. It's going to launch my Chrome thingy and Swagger. And let's see if anything shows up in our structure. Oh, okay, so I'm starting to see stuff here. Things are starting to show up in my structured logs, because over in my extensions here where I have add logging, I've also included as part of the exporters, it knows that if there's a OTLP endpoints environment variable, basically, then it will add the exporters for logging, for metrics, and for traces. That's this bit of code right here. So by now adding the logging generators, the exporters now light up, and those get pushed out immediately. But if I go to execute something here, let's go try it out. Hello, NDC, execute. We'll see logs show up. Oh, here we go, more logs show up. But on the traces side, it's still lacking. There's, I guess, Mongo is showing up for whatever reason, but we don't see that full trace of that API operation there. So we now need to turn that part on as well. Now, tracing is an opt-in collection. So there are things that are generating spans, but that can be expensive to kind of keep track of. So you have to opt in to listen to these different tracing sources. So that's what we see right here. I'm going to uncomment this here. Yeah. And the important bits here, as I say, services that add OpenTelemetry with tracing. And now I'm adding all the instrumentation. And these are just listeners. They're listening for those activity sources with well-known names. And when I have those sources listened to, that's going to then export those spans out into our UI. I'm going to uncomment one just to, okay, actually, we'll leave that there. So this says add ASP.NET Core instrumentation. That's the server part. Add gRPC client instrumentation. We don't have gRPC, so we could probably safely comment that out. HTTP client. We do have API calls between these different systems. We are using EF Core. We're doing messaging via in service bus, so that's this source here. And notice this is picking up all of the activities as part of that. You can name specific sources If your third-party telemetry source has like multiple different things that it's publishing out, you can say, I'm only interested in this specific event versus those other specific events. That can be done here as well. And I'm doing Mongo, so this is the Mongo source as well. The packages that publish these out will tell you what to put in these strings here. Sometimes they actually do have them as a published like property or constant you can reference, or it's just a name that never changes. It's whatever. All right, so now let's see what happens here. Starting up again, and we'll try it out, add some other message here, execute, and what do our traces see show now? Well, this one kind of has some stuff, but if I look at the console logs, there's much more stuff going on. I could see like way more things that are getting executed than what's showing up in my traces, so something's still missing here. So this is the case where sometimes the source of your telemetry data needs to be turned on. In ASP.NET Core, starting with ASP.NET Core 5, the OpenTelemetry generation is turned on by default. You don't have to do anything to turn that on, but that's not always the case. Sometimes you have to go explicitly turn it on, and in Service Bus is one of those things where I have to go in here and say, hey, you have to turn on OpenTelemetry, and this is very specific to in Service Bus, but then the MongoDB extension has that as well. What did I hosted service? We don't need that. Similarly, in the web application, there was where did you go? There we go. Enable OpenTelemetry, and finally, in the worker service, we have enable OpenTelemetry. Okay, now, when we execute this operation, now we'll see a much richer trace that shows a ton of things going on with this one operation. I intentionally made this like crazy, lot of stuff going on here, just to show like a very deep distributed trace. But just by sort of lighting the activities on and then enabling it for these specific components, without any sort of user code that's targeting Zipkin in this case. Actually, let's open up Zipkin. Here, if I open up Zipkin. Oh, nothing in Zipkin. So if I want to now export these out to different things or have different things based on different situations or different environments, this is now the last part of the demo that I'll show here. So let's go back to the presentation. There we go. The last part I want to show is the collector. Now, I didn't show metrics because it's just like another thing on there. You just like enable metrics, export the metrics, and now they show up. Huzzah. The last one I want to show is collectors. So in this picture where I've migrated to OpenTelemetry, if I want to target these specific providers over here on the left, like Splunk, Zipkin, or Datadog, I have to extend my exporting logic to make sure I can export from OpenTelemetry to that third-party provider. But there's also this component known as the OpenTelemetry collector. The OpenTelemetry collector is a centralized collector of telemetry data that instead of your application code directly talking to those different telemetry servers, I instead funnel all those through a centralized collector. So what this allows us to do is to remove any dependencies from application code to observability tools. So I won't have to reference Zipkin in that service defaults or in any of my user code application code. It also lets us centralize all the policies for sampling, filtering, and redacting. And also lets us offload processing from our applications. So instead of my applications now directly talking to Splunk, Zipkin, and Datadog, or whatever telemetry service you have out there, instead I have an OpenTelemetry collector application in the middle that all of these communicate via OTLP to the collector that will receive, process, and exports, then out to these different providers. And I'll show you just a quick example of what that looks like here. Come on, Parallels, you can do it. Oh no, not Parallels. This is going to be here in our Aspire application. In our app host, I'm going to enable the OpenTelemetry collector with forwarding. And so this is an extra container that's running that will collect the information, but also forward that, also take over. Right now, all the OpenTelemetry data goes to the Aspire dashboard. I'm going to put this collector between the Aspire dashboard and my application. And finally, configure it to this. All this isn't that important, except for saying that I'm going to have an exporter for Zipkin with this endpoint. And then when I pump out traces, I'm going to pump out to Aspire and Zipkin and Jaeger. So with this in place, now in my Aspire dashboard, I can look at traces here. Traces show up. I can go execute the UI, executes. There it shows up here. Here's that lovely trace. But now I can go over to Zipkin. And now that exact same trace shows up here as well, without me having to add any reference in any of my applications to Zipkin whatsoever. It is strictly now through this collector that is able to then accept this information through the OTLP API. All right. So let's wrap this up. So one of the things I like about this kind of architectural approach is it gives me what I like to call exit ramps. So I don't have to finish the entire migration of the entire process for me to get any value. Instead, I could look this as a component by component and signal by signal process where I can get an exit ramp that says, okay, if I just make it this far, I've actually improved my situation. So I can just migrate my generation logic from custom whatever code over to OpenTelemetry, and I'm in a better spot than I was before. Or I can then go, now let's go to exporting. Let's migrate the exporting logic off of like custom log4net or serial log configuration over to like just the stock sort of thing there. Or finally, the collector, I can say, okay, now that we've done the first two, I have another exit ramp that'll still provide me value. I can get off of any of these stops and still have added value to my observability solution. So thank you all very much. If you want to see this full working code in practice, my GitHub repository, there's a presentations repository on my GitHub right there. So all this code and the slides will be on there, like a fully working example. Otherwise, I'll be hanging out afterwards for any questions. But otherwise, I hope you'll have a great rest of the conference. Thank you so much.